All right. Okay, you don't have to be totally silent. It's fine. So we are starting with our first unit, which is rational expressions and equations. And we're just going to start by reviewing fractions, right? One of the reasons I'm doing this unit, it's just fractions. Everybody loves fractions. I'm sure half of you, no, whatever. Okay, so reduce the following fractions to lowest terms. We have 4 over 14. If we're going to reduce that, how do we do that? How do we reduce it? What do you look for? Factor. Common factor. We're looking for. So is there a number that goes into both 4 and 14? 2. It's not really the answer to the question. The answer is yes, there is, but that number is 2. So what are we going to write 4 as? So we'll go with, well, 4 is 2 times 2. What's 14?
7.
So 2 times 7, right? How many times does 2 go into 14? It's 7. Try and write a 7. 7. Cross off these 2 2's, and we're left with 2 over 7. Okay. You necessarily have to do it that way. Well, if it's more complicated, it's kind of handy to have something to fall back on, right? You might just be able to look at that and say, oh, that's going to be 2 over 7, which is fine. Okay. So if you can just reduce it, good on you. 21 over 45. What goes into 21 and 45? Yep. 3.
Which would be 7 and 15.
Well, let's work it out. For those that few of us, the small fraction of us that are not comfortable with fractions, might want to write this out, right? So we figure out, okay, 3 goes into 21, 3 goes into 45. 3 goes into 21 7 times. 3 goes into 45 15 times. Okay, like 9 also goes into 45, right? But that's not really helping us because we know 21 really is only 3 times 7, right? Or 1 times 21. So if it's 3 times 7, then we want to say, well, does 7 go into 45? No. Does 3? Yep. Okay, don't be afraid to use your calculators. You will have them with you the entire time. Okay, cross off the 3's. When we do that, when we're canceling, just put down little 1's. And we're left with 7 over 15. Okay, 42 over 24. Goes into 42. You start saying, well, 2 goes into 42. Yep. Does 4 go into 42? No, 42 is like 6 times 7. 24 is like 6 times 4. Okay. So let's go with that. Let's say you just did 2's though. What would happen? So I'm going to go, all right, that's 2 times 21. That's 2 times 12. I have 21 over 12. Okay, so, oh, hang on a sec. 3 goes into 21 and 3 goes into 12, right? So 21 is really 3 times 7. And that's 3 times 4. And those cancel. And then we get 7 over 4. Okay. So far, so good. Fractions aren't so bad. Here. Watch this. Here's your calculator. Clear. What did we say? 42 divided by 24. See? Oh. See? So here's how you can reduce a fraction on your calculator. Let's do 21. 21 divided by 45. Math. Enter. See, 2 fracts, right? It says convert it to a fraction. Enter. So now it just says do 21 divided by 45 and convert it to a fraction. And then you hit enter to say do it, and it's 7 over 50. Okay? Now we do have to understand that it is 3 times 7, it is 3 times 15, but we can also now understand that should I have numbers to reduce, then my calculator will do that for me, right? I can just have my calculator do it. Okay. But it is still really important to know that it gets split up. We look for this common factor. Evaluate. What does evaluate mean? Goes back. Oh, I'm giving you a formula. Evaluate. Here's what evaluate. So, these are the math directing words. Any word along here in bold is a word you may see on the diploma exam, and it has a specific meaning. And when I give you your formula sheets, which won't be for a while yet, it'll have these directing words on it. So evaluate, what does evaluate mean? What do you think? Evaluate means, yeah, kind of. When it's been evaluated, what should you have? An answer. Let's call it a value. We're going to get a value. What's a value? It's a number. What are we going to do? Evaluate, we're going to come up with a number. So evaluate. Here we go. Find a numerical value or equivalent for an equation, formula, or function. So evaluate really just means come up with the value. Okay. So what is 3/8 plus 1/2? All right, how do we do 3/8 plus 1/2? I mean, besides going it's 4/10, which is like totally wrong. What do we need?
You need make the denominator the same number.
Yeah.
By that, you would multiply 1/2, multiplied by 4, which would make 3 bottoms.
So when we say denominator same number, what do we commonly say we're looking for? A common denominator, right? So in order to add fractions, we need a common denominator. And that common denominator is going to be a number that both of these guys go into, and it is 8. So we got to change the 1/2 into something over 8. Okay. How do we do that? Right. So the 3/8 is fine. So what are we going to multiply the 2 by to get an 8? 4. Right? So 2 times what gives you 8? 2 times 4. If I multiply the 2 times the 4, what do I do with the 1?
Times it by 4 too.
Yeah, times it by 4 as well. What is, or evaluate, 4/4? What's 4/4 equal to? 1. If I multiply a number by 1, what happens to that number? Stays the same, right? So when we multiply by 4/4, we're really just multiplying by 1. It's going to stay the same, but it's going to change from 1/2 into what?
4/8.
4/8. Is 4/8 the same as 1/2? Yeah, right? But now, we can add these guys. So we got 3/8 plus 4/8, and what's that equal to?
7/8.
7/8. You know the hardest thing with fractions? Adding and subtracting. Multiplying and dividing is trivially easy. Right? Multiply these guys and multiply these guys. Division is just flip that guy, and then multiply these guys, multiply these guys. Adding and subtracting is a pain because you have to change them. They need this common denominator. What's a common denominator for 5 and 4? So in part B. Okay, 20, right? How'd you get that? Well, you can say, well, 5 times 4. You can always find a common denominator just by multiplying them, right? You say 20. Could have done that here and said 16. That's overkill, though, right? So what I do if I'm looking for a common denominator, I start with the bigger number and I start doing multiples of it. Right? So 5, no. 10, no. 15, no. 20, yep. Start with a bigger 8. Well, 2 goes into 8, right? So, okay, we need 20. So what are we going to do to the 4/5? To turn it into something over 20.
Multiply both sides by the other side.
So multiply top and bottom. It's not really both sides. Top and bottom. Multiply the numerator and denominator by how much? I want to turn 5 into 20.
4.
4. Put a 4 on the bottom. What do I put up top? Goes up here.
16.
No. What goes up here? Look at what I'm pointing. Not what do I end up with. You're jumping ahead. What goes up here? Here. 4. Because what do we want to multiply by? 1. But it's a special one. It's the one that looks like 4 over 4. Why? Because we want to change the 5 into a 20. Okay. If we don't multiply by 4 over 4, if we multiply by something else over 4, we're not multiplying by 1. We're now changing the value. Right? We're not getting an equivalent fraction. This is 16 over 20. 16 over 20 is 4 over 5. Or your calculator goes 16 divided by 20, math enter. It's going to say 4 over 5. But we got to subtract 3 over 4. What's 3 over 4 got to be multiplied by? 5 over. 5 over, or 5 under. The 5 is under here. What goes up top? Same thing, right? What are we multiplying by? 1. What does 1 look like? 5 over 5. Why? Because we want to get a 20 down. Okay, what do we end up with? Minus what? We know the bottom is going to be 20 because we made it.
15.
Yeah, what's up top? 15. What's 16 20ths minus 15 20ths?
1.
1 20th. All right? Okay. You do the last one. Give it a try. No penalty for getting anything wrong when we're doing this, right? Nobody's going to know unless you show your friend and say, look at the dumb thing I did. You're not going to admit to anybody. Oh, I messed that up. What's the lowest common denominator? So start with 15. Does 12 go into 15? No. 30? No. 45? No. 60? Yeah. Okay, so we're going for a 60 in the denominator. You got to figure out, what do I multiply 15 by in order to get 60? Multiply 12 by in order to get 60. I think that's right, but check it out. I'm going to make lots of mistakes. Last morning I made a ton of mistakes. Only a few on purpose. Yeah, most time. But when I make mistakes, you just point out, wait, so isn't that like, how'd you get that? You can always, how'd you get that? Well, we ended up with negative, right, because 25 is bigger than 16. So we ended up with a negative 9 over 60, and then we have to reckon, I can reduce that, right? It says express in simplest form. So that means just reduce it. Right, if it's reducible as a fraction. Okay. Now, if it is, we just do it on our calculator, right? 4 divided by 15 minus 5 divided by 12, math enter. What's that look like? So this will do fancy fractions, but you all don't have fancy fraction doing calculator, but you can always do this. So if I want to do 4 divided, I'm just going to bracket 4 divided by 15, bracket, minus, bracket, 5 divided by 12, bracket. Now if I hit enter, it's going to give me a decimal. Right? I don't want that. I'm going to go straight to the fraction. So I go math to frac. So it says do this, convert it to a fraction, and we get negative 3 over 20. If you have the older TI-83, it's going to be negative 3 and then a slash 20. Right? Well, it doesn't display the fancy fractions. Okay. Doesn't matter. If at any point you have any questions, please. Now we do the easy stuff. Let's do the hard stuff first, right? It's like, why is this in the order of like hard stuff? What is 1/4 times 2/3? How do you do? So how do you multiply fractions? Somebody else. You already know this stuff. You don't get to answer any questions this unit. Yeah. How do you multiply a fraction? There you go, my calculator. Yep.
Multiply the numerator by the
Yeah.
numerator.
Multiply the numerator times the numerator, right? Or put it in for quick. Multiply the tops together, multiply the bottoms together. Okay, so it's going to be 1 times 2 over 4 times 3. Which is going to be 2 over 12, which is actually going to reduce and be 1 over 6. Now, normally I'd say, hey, we could do reduction right in there, right? Since we're at 1 times 2 over 4 times 3, I can cancel the 2 with the 4. 2 goes into 2 once and into 4. I'm going to say, don't bother with that. Just multiply it out, get whatever, and then simplify that. Okay? It's easier, and you make less mistakes than if you're trying to do cancellation along the way, right? Multiply the numerators together, multiply the denominators together, and then simplify that, right? How do you simplify 2 over 12? You go 2 divided by 12, math enter. So this is equal to 4 times 5 over 15 times 6. You use your calculator. That's 20 over whatever that is. 90, maybe. And if you're not sure about reducing, then you go 20 divided by 90, math enter. You really shouldn't need to. They both end in zeros. You should just go to 2 nines. But hey, nobody's looking to see if you used your calculator to do a calculation or not. Nobody else cares. Okay. Well, they shouldn't. They should be busy with their own work. They should be looking at you doing stuff. Uh-oh, division. How do we do division? Fine, you can answer.
For the second fraction, you flip them, and then the division sign turns to a multiplication
Right.
sign.
Anybody got a fancy way of saying that? I've heard kiss and flip. I never use that. They multiply by the reciprocal. But I've heard kiss and flip. So kiss, that's the x, right? And then flip. So we're going to change division into multiplication. You can't do the division, right? But you can go 3/10 times 15 over 4. So that's a step, right? Now, I mean, we're not in grade 4 or whatever, just learning fractions for the first time. We are just reviewing fractions. But the concept, though, of dividing one fraction by another is going to carry forward when we actually get into the rational expressions, right? So we're just kind of reviewing fractions now because that's all rational expressions are. They're kind of fractions. So that's 45 over 40. Math, enter, reduce, whatever. 9 over 8. Okay. You don't have to show the reduction of that, right? It's a calculator thing. Just go 45 divided by 40. Math, enter. Any questions? Easy. Take it back to junior high. I don't know when you guys do fractions. Junior high? Elementary? All right, now the new stuff. Rational expressions. Okay, what is a rational expression? That's the title of this unit. It's a fraction that has a polynomial. What's a polynomial? We'll get into that in a second. For both the numerator and the denominator. So a polynomial is like a quadratic, right? Like x squared plus 7x plus 12. It's like a linear function, right? You did linear functions in grade 10, right? Hey, let's graph 2x plus 7. How do you do that? Well, find the y-intercept, which is 7, and you got a slope of 2, and there's a straight line, y equals 2x plus 7. That's called a linear. So x plus 15, that's a linear function. But it's a polynomial function, right? They're known as polynomial functions. 4x squared plus 8x, that's a quadratic. Okay. So think of a rational expression as an algebraic fraction. Right? So it's a fraction, but it involves polynomials, right? It involves some algebra there. X plus 2 over 3x minus 1. Hang on, I'm just going to pause this. Okay, so here's the book. So the 4.1, that's what's on your timeline. You're going to see 4.1, so you know that it's chapter 4, because where else would you start? But in the middle, right? Chapter 4. Then we'll go back to chapter whatever, and then we'll jump forward. So 4.1 is equivalent rational expressions. But what I want to show you is, okay, how do I use my book? I'm looking through the textbook. What's in there? What are the features of this book? So let's take a look. some stuff here. So here is a definition. So anything that's written somewhere, right? Here's like somebody's solution to something. I like this book. It's actually a pretty good book. Because here they're explaining, this is what I'm doing, right? Like here's what's being done, but this is what I'm doing, right? And then if there's a thing, this gave me a rational expression. And you go, what? What's a rational expression? Oh, a fraction that has a polynomial for both the numerator and the denominator. By the way, the number 1 is a polynomial. The number 17 is also a polynomial. Okay? So you can just have number up top. It doesn't have to be 2x over 3x plus 4. It can be 10 over 5 plus x. That's a rational expression. Okay? So the book has definitions in it, right? Here, they're solving something, but here's the explanation, right? So if you're looking through this, it's not just sort of like, wow, there's a bunch of math. It's like, okay, but what about it? Oh, this is what I'm doing. Right? So it's very handy. Don't be afraid to use the book. It's not bad, except for that one unit. It's there. Determine the non-permissible value. We'll come back to that. That's later. Here. Okay, so, and you notice 4.1 was equivalent rational expressions. Equivalent rational expressions. So it's like equivalent fractions, like adding and subtracting. What do we need? A common denominator, right? How do we get a common? Oh, that half has to become 4 over 8. 4 over 8 is an equivalent fraction to 1/2, right? Multiply top and bottom by 4. 3 over 5 became 12 over 20, an equivalent fraction. Well, rational expressions are just algebraic fractions, right? They're fractions that have variables in them. So we can get equivalent ones. How? By multiplying the original by a fraction equivalent to 1, right? How did we turn a half into 4/8? We multiplied by 4 over 4. What's 4 over 4 equal to? 1. Just multiplying by 1. We are now going to multiply by a rational expression equivalent to 1. Determine. What's determine mean? I know you know that. To specify, did you memorize this? What's determine mean? What's a short form of determine? I say determine, you say what? Show your work. Come on, I've been drilled into you like 1,000. Okay, every day from now until the diploma exam, you're going to say determine, you're going to say show your work. Here's what determine actually means. Find a solution to a specified degree of accuracy, that's the whole rounded to the nearest tenth, rounded to the nearest hundredth, right? To a problem by showing appropriate formulas, procedures, and or calculations. In other words, show your work. And then round it properly. Okay. You will see determine on the diploma. Where? In the written stuff. You can't show your work on a multiple choice, right? They'll never say in a multiple choice determine. Right? So determine means show your work. But in the written, you're going to see determine. It's a directing word, which I'm going to give you this list out. It will be bolded on the diploma. So you might not know what it means, but you'll know that, ooh, I should have known what that means because I had a sheet with all of those words on it. Don't memorize them, but just look through it and just kind of, we'll talk about the important ones, like determine. Okay, determine, which means what? Show your work. Good. 2 different rational expressions that are equivalent to each of the following. All right, how do we get an equivalent rational expression? We multiply the original by a fraction. So, simple, we could just say, all right, let's take 4x squared plus 8x over 4x, and we're going to multiply that by 3 over 3. Multiply it by 3 over 3. Okay, do it. What do you got? There's a good chance now you can make mistakes, doesn't cost anything. But if you do make a mistake, you want to look at it and figure out what mistake did I make? What did I do wrong?
Why are we multiplying by 3 over 3?
Because I arbitrarily chose 3 over 3. 1 over 1, not good, because you'd end up with the same thing. 2 over 2, too easy. 3 over 3, just hard enough. Okay, did you get that? See, just hard enough but doable, right? Everybody has success. It's good. You're starting to think I can do math. And then I'm going to hit you with this, and then you're going to think, ooh, well, let's give this a try. So we're going to do one more. It said 2. So we did an easy one, right? We just multiplied by a number. Okay. What if we multiply by another rational expression, right? But it's got to be equivalent to 1. So whatever I put, it's got to be on the top and the bottom, right? It's got to be the same. What's x plus 2 divided by x plus 2? 1. For all values of x. Except for when x is negative 2, but hang on, we'll get there in a minute. For now, okay, do it. Give you a hint. Do this first. Okay. Maybe this too if you like, but that's important. The bottom part's not.
Is the bottom, shouldn't the bottom be 4?
Where?
Like,
Oh, in the original? Yeah, it should be. Good. You get points for the day. Hey, you copied it wrong. Oh, you're right, I did. It's called a transcription error. As long as you're showing all of your work, if you just make a reasonably simple transcription error, they won't take any marks off. You make a transcription error that reduces the next 5 lines of work down to 1 line of work, you're going to lose a lot of marks just because you changed the question totally. I apparently just can't copy, aka a transcription error. As long as you're showing all your work, if you end up reversing 2 digits in the end, if it's numeric response, you're hooped. Sorry, right? You're filling it in on a form, it's not going to know that. But if it's written and somebody's marking it and they just say, oh, yeah, you showed all the work, and then you just reverse these 2 descriptions or 2 decimals, that's fine. So how are you going to multiply the top together? What's the magic word that goes with how to multiply the top together? Starts with an F. Foil. You're going to FOIL it, right? When you FOIL, how many products do you end up with? 4. Which will then likely collect into 3, sometimes 2. In this case, they will collect into 3. Or not. No, they will.
They will.
Yes.
I already did that.
Yeah. You did it. Okay, you got that, huzzah, you're off to a great start. If you didn't get that, just take a look at yours and try and figure out, okay, wait, what did I do wrong? Or what did he do wrong? Which is equally likely. Unless a whole bunch of people agree with me, and you're wrong, and we're all right. It's the majority rules, that's how math works, right? It's like democracy. No. There is a right answer, we can find it, right? As long as we follow the procedure. It's like baking a cake. Let's make it an easy cake. It'd be a Betty Crocker cake. That's easy, right? Comes in a box. The instructions are on the box. Put the mix in a bowl. Step 1. Step 2, add 1 egg. Well, I don't know if it says break open the egg first, but I think that's implied. But add 1 egg and half a cup of milk, mix it up, put it in an 8x pan, stick it in the 350 degree oven, blah, 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 right? Take it out a half hour later. There, cake. So Betty Crocker's cake mix simple. This is how you do math. Right? You want to know how you do math? Make it cake mix simple. You need to come up with a series of steps for you, not for the person beside you. They might do something not totally different, but you come up with a series of steps for you that's going to work. And then you follow those steps. That's it. Like making a cake. Follow the steps. Now, does that mean you're going to always get the right answer? No, you'll make mechanical errors. Sometimes you might multiply wrong or something like that. But what I want to see most importantly is you're following the steps. If you're following all the steps, I will forgive by taking off a half a mark for each mechanical error. Unless it's multiple choice or numeric, then your group is to 0. But those are only worth 1 mark each, right? You got a 3-mark question, you make a mechanical error, like you get a 12 here or something, it's going to cost you a half mark, as long as everything else is done correctly. Because it's the procedure that counts, right? Not the end result. But you eventually become a doctor. Then the end result really counts. The procedure should be done properly. Okay, any questions? But that reduces, right? We don't want to reduce, right? We're looking for an equivalent. And the reason maybe we're looking for an equivalent is maybe we have to add this to something that has a denominator of this. And so we say, oh, I need to make an equivalent rational expression such that I'll have this denominator. You'll figure out, oh, if I multiply by this, that'll give me the denominator I want. Oh, but wait, the step is this over this, right? This has to be 1. I'm just multiplying by 1, but this has to be x plus 2. So this is x plus 2, and carry over procedure. Then take that result and do something else with it. All right, 3 minus 5x over 4 plus x. Okay, let's do an easy, but not as easy as the first one we did easy, because you can now ramp it up a bit. You've seen some stuff. So how about 7x squared over 7x squared? Still has to be 1. I'm just going to throw a letter in there. We call those letters variables. I'm going to put in a variable. Anytime I see a binomial, I like to throw brackets around it, right? Just in case. Just reminds me, hey, oh yeah, use the distributive law when you're multiplying this, right? Do yours, look up. Feel happy, feel sad. If you feel sad, figure out why. What mistake did I make? Or what mistake did he make? Why does it not agree? Come out of this, I should do that stuff in grade 4. And then, let's do one more. Okay, what was it? Let's get this right this time. 3 minus 5x over 4 plus x. 3 minus 5x. Okay. See, binomials, put them in a set of parentheses, right? Especially because you're going to be multiplying. What would you like to multiply by? Okay, and not just 5 or something, right? So I want a binomial. Give me a binomial. Pick a binomial. Any binomial.
21x cubed.
Don't be silly. First of all, it's not a binomial, and second of all, I want numbers that I can't do in my head. Pick a binomial. Binomial, 2 terms. You know, like this, x plus 2. Pick a binomial. X plus 4. Thank you. Ooh. That's going to make the bottom interesting. Okay, do it. One illness type of vaping has killed a 3rd person and may be a new worrisome disease. So if you're vaping, you might want to stop. Just saying. People are dying now. And it's not like of lung cancer 35 years down the road kind of thing. It's like, so what are we doing? What's the magic word?
Foil.
Foil. How many products are you going to get?
4.
What's it going to collect down to?
3.
So we should end up with 3 terms top, 3 terms bottom. There should be an x squared term, an x term, and a constant. And then rewrite the bottom so that it's in order, right? Do the x squared, then the x, then the number. And do the same on the top. And then just one person say, hey, that looks right. Or correct it. Okay, did I do it? I messed up. What's your next? Well, minus 5. Minus 5. Good.
Isn't it 20x?
20. Oh.
Negative 28.
Well, when you say, hey, messed up. On purpose, I might know. I didn't. I just do it. So minus 17x plus 12. Over. Good. Having a bad day?
I'm just making sure.
We need a preseason, right? Jump in. Bam. It's a school year. Yes, does that.
3 days.
Play some preseason games. NFL goes overboard for preseason games like that. CFL's got a couple preseason games. Baseball, they take about a month, but they're going to play 162 games, so that kind of makes sense. All right, does that look right? See, so when you don't agree with me, just remember there's as good a chance that I'm wrong as you're wrong. Don't always assume, oh, it's a teacher, I'm wrong. I'm just going to erase this and write what he wrote. Okay, fine. We can both be wrong. We'll be wrong together. It's important. We stick together. Okay, is it good now? Right. I don't have answers to these, right? Because I said pick a thing. So, right? Pick this. I didn't pick that. Non-permissible value, aka NPV. And really, it's all going to be about restrictions. So, non-permissible value. Where'd the book go? Here. Determine the non-permissible values. Okay, the value of a this is going to be repeated on the sheet in front of you, right? Or something similar to it. But just showing you in the book, right? You're looking through the book. You see the stuff there. If anything's highlighted in green, you're going to see in the margin, left or right, depends on the page you're on, the definition, right? So you can look over and say, all right, what is it? It's the value of a variable that makes the denominator of a rational expression equal to 0. For example, 10 over 15 plus x is undefined when x is negative 15, right? Because then you'd be trying to divide by 0. We can't do that. We can't divide by 0. So, let's go back here. Non-permissible value, the value of a variable that makes the denominator of a rational expression equal to 0. Remember, we cannot divide by 0. NPVs, non-permissible values, are determined from the rational expression after the denominator has been factored, but before it has been simplified. Okay? So if we have a denominator, we may have to factor it in order to figure out the NPVs. Now, an NPV is where, so you got this 15 plus x here. An NPV is where we say x is equal to negative 15, right? That is the value that is not permitted. What can't you put in there? I can't put in 15. What is the value you cannot put in? I cannot put in x equals negative 15. 99.97% of the time, we do not state it as a non-permissible value. We state it as what's called a restriction. And the restriction here, so the restriction is, what can't you put in? So for non-permissible value, we say x equals negative 15. The restriction is x cannot equal negative 15. If I ask you for non-permissible value, you give me a restriction, it's fine, no marks off. If I ask you for restriction, you give me the non-permissible value, it's fine, no marks off. Okay? 99.7, I made that up. 95% of the time, that's made up too. Most of the time, you're going to see it as restrictions. On the diploma, you'll always see it as restrictions. I didn't make that one up. They always list them as restrictions. So they always just say where this can't be that. Okay, back here. So determine, and then it says, and then state the restrictions, right? So for restriction, you're just saying X can't be this. You can't do that. What can't X be? 3, right? Why? Because this would be 0, right? We'd have, so how do you solve it? If you want to get technical, you go X minus 3 is equal to 0, so X is equal to 3. Right? Just set the denominator to 0, solve for X. Now you want the restriction, X cannot be 3. Okay, so to get the non-permissible value, set the denominator equal to 0, and then figure out the values, and then write it as X cannot be. Okay, X times X plus 5 is equal to 0. What's X?
Not equal to 0.
So it can't be 0. Anything else it can't be? Right, so it can't be 0, can't be negative 5. So the restriction is negative 5 comma 0. You don't have to, if you don't list it that way, I'm okay. I don't care if you do them. But most of the time you're going to see them from low to high. So you'll see any negatives and then just left to right on the number line, right? Starting over there, going that way. But if you write it as 0 comma negative 5, it's fine. Okay. All right, what can't X be? Oh, wait a sec. We got to factor this. So if the expression is more complicated or not in a factored form, not just one thing, right, like x minus 3 or like dx plus 4, then we need to factor it, right? Now, you can just look at this. You don't have to show work. Well, you should factor. You should show that work, but otherwise you don't have to. So what can't x be? 0 or 6, right? Everybody cool with that? 0, 6, see where it came from? This guy here, we could just state it. State is not a directing word. State is just write your answer down, right? State. What is the restriction? State the restrictions, what you're going to see. So, what's the restriction? Negative 4. What do we got to do to the next one?
Factor.
Yeah, like factoring it just makes it easier. Right? You could set it equal to 0, but you know, it's like, okay, so I'm going to factor that. Negative 5 x plus 4. Anytime you factor, and I don't care if it's just a common factor, just multiply it back out. Because in this one, you got to make sure your signs are correct, right? We're going to pull a negative 5 out as a factor. That leaves me with x plus 4. Because when I expand negative 5, x plus 4, I get negative 5x minus 20. So if this is your factor, just go negative 5x minus 20. Just make sure your signs are correct. Most of the time, when you make mistakes on this, that's because the signs are wrong. What can't x be? Negative 4. Okay. You can also do this. Negative 5x minus 20 is equal to 0. Negative 5x is 20. X is negative 4, which means the restriction is x cannot be negative 4. Next one. What do we got to do? So in this case, not much, we do have to factor the denominator. It's not a simple expression like x plus 4. Even negative 5x minus 20 is relatively simple, right? Because it just solves. You can set it to 0. Okay. So right now, we're not interested in this, right? I'm interested in this. Okay. Factor that. You should do a little bit of the work. Do a little bit of the work over. 2 terms with a plus sign. Only thing you can do with 2 terms with a plus sign is the greatest common factor. Okay. two terms minus sign, maybe there's a difference of squares. But this is two terms with a plus sign. How about this? Okay. Anytime you factor, be it a greatest common factor or factoring a trinomial, FOIL it out, multiply it back out, just make sure that you factored it. Okay? It's not grade 10 where you're just going to get marked on your factoring. It's like you need the non-permissible value. In order to get that, you have to factor. So your factorization has to be correct. Then you can state. Okay? And I'm just going to fire through the rest, and you can fire through the rest, and I'll show you how to do that. No. This is the world's greatest pencil sharpener. So I'll show you. So, it's made by Mitsubishi. It has a whatever engine, no. However many horsepower, you can do it. So this should stay out. It doesn't. It's kind of broken. Made by Mitsubishi. Okay, so pull it out, hold it out, and what I call these the ears. So just open up the ears, or close the ears, take the pencil, stick it all the way in, and then let the ears go. Okay? Now what happens is it's sitting there. The sharpener is going to pull the pencil in. Okay? This is like spring-loaded. So then you turn it around, assuming you're right-handed, left hand on top, you turn it clockwise, so you can hear it sounds like you're sharpening, right? Okay, now what does it sound like? Nothing. So you know the electric pencil sharpener, you take this pencil like this and you get it back into this. The electric one just chews it up. This sharpens perfectly. Right? How sharp is that? Don't look too close. You put it across. So it sharpens it perfectly. It stops when it's done. So for those of you Luddites using wooden pencils still, that's there for you. That's for you, Luddites. Bring all your wooden pencils. Seriously, I used to have people bring like 5 or 10 wooden pencils with them to sharpen them all in here, because it is. Then you went in ordered zone. I use a mechanical pencil. But you have to sharpen a wooden pencil. And if you have pencil crayons, your NARD or something like that, it has a special setting for those. Just ask me. Like special settings, like flip the switch. There's a little orange dot on the side. Because pencil crayon, if you sharpen it really sharp, it's just going to snap, right? They're not a hard lead. So it has another setting for pencil crayon where it will sharpen it, but you won't get the really fine point that'll just break it. I'll show you how. Meanwhile, do these. Don't worry about the top, right? So we're not worried about the, we're not worried about the, whatever, numerator. Okay. I'll come back, I guess. I just want to see what's left. Okay. Do those. So there are no restrictions in H, right? X squared plus 4. Think about it. You square a number, you're going to get a positive value. The smallest value you can get out of x squared is 0, right? You square negative, you just get a positive. I square negative 4, I'm going to get 16. So the bottom, the lowest at x squared could be a 0, and then I'm adding 4, which means I can't ever get a 0 in the denominator. For the last one, factor out of 3, then it becomes a difference of squares. Now I have 2 non-permissible values, or restrictions. And for the other one, factor out the x, you got a 3x minus 7. You can just look at that, like we can solve it by inspection. Okay, just change the sign on the 7 and put it over the 3. Or you can just solve it equal to 0 and then write it out. All right? This will all be available. We're 50 minutes and 23 seconds in. All right. I just want to move a little bit because we've got to get through a couple more things, and it's Friday. Okay, of the following rational expressions, identify the equivalent rational expressions. Explain why they are equivalent. Okay, so let's think about this. How would you get from 81c squared to 243c squared? What would you do?
Multiply by 3.
Yeah, you multiply by 3. Okay, so here we go, times 3. If I multiply this by 3, what would I get? Let's make this. So I have 9c minus 9 over 81c squared times 3 over 3. So I'm going to get my 243c squared. What do I get up top? So, are these the same? No. So in this one, they multiplied this by 3, but they divided the top by 3. Actually, negative 3. So they're not the same. Okay. How would I get from 81c squared to 729c cubed? So now I have 9c minus 9 over 81c squared times, and I want to end up with 729c cubed. So 9c multiplied by 9c. Put a 9c up here. Will give me 81c squared minus 81c. Are these the same?
Yeah.
Yes. Okay. So what's equivalent? Equivalent to. So basically it's just looking at, can I turn one of these into the other one? Right? And just work with the denominator. How do I turn that into 200? Multiply it by 3. Right? Use calculus. Go 243 divided by 81. Okay, multiply by 3. If I multiply the denominator by 3, I have to multiply the numerator by 3, and that's not going to give me 3 minus 3c. Okay, not equivalent. Then we try it over there, and we see, yeah, okay, these two are equivalent, right? All right, applications. Josephine is an accomplished long-distance runner on her school track team. She has completed 3 kilometers of a 10-kilometer race in 15 minutes. She wants to finish the race with an average speed of 0.25 kilometers per minute. Determine the time in minutes that Josephine must run the remaining 7 kilometers. What does determine mean? Show your work. What I gotta say? Show your work. Just get it. It should be automatic. Show your work. What's 8 times 7? 56. See, I say 8 times 7, you say 56. I say determine, you say show your work. Okay. Let the time needed for Josephine to finish the race be... Okay. So... what are we going to get for, so she's run for 15 minutes. How long is it going to take her to finish? Okay, we don't know that, so we're just going to let that be x. Okay. So we have to define a variable. Therefore, her average speed for the race, so average speed is going to be total distance divided by total time, right? Speed is distance over time. Okay, so speed is equal to distance over time. So her average speed we want to be 0.25 kilometers per minute. Oh, no, let's just do this with speed. So we'll say speed is equal to distance, so it's a 10K race, divided by time, which is going to be x plus 15. Right? Because she's already run for 15 minutes. She's going to run for X more minutes. And that's going to be her average speed, right? Total distance divided by total time. If Josephine wants to have an average speed of 0.25 kilometers per minute, the equation needed to solve. I give you the secret to math. You're my 10C class. What's the secret to math? All right, I'll give it to you again. You may have forgotten. Formula, substitution, answer. So, I mean, that doesn't work for everything, but for most math, it's like there's some formula. So we have a formula, right? Speed is 10 divided by x plus 15. We're going to substitute into that formula. So we know the speed is 0.25 kilometers per minute. Another way to say 0.25 is 1/4. Right? 1/4 is the same as 0.25. Is equal to 10 over x plus 15. So, formula. We actually had to develop that, right? Speed. Average speed is total distance divided by total time. S is equal to 10 over x plus 15. We have a speed that we want. She wants us to run an average speed. And, therefore, the solution is, so now we have to solve this. How do we solve such a thing?
How's that?
Cross multiply, I hear. You may not have said it, but we only have a couple minutes left. So we cross multiply. So 1 times x plus 15 is equal to 4 times 10. X plus 15 is equal to 40. And x is 25. Don't worry, solving rational equations, which is what we just did, is the last thing we do. Okay. But this is just showing you an example, right? So if she runs for, what the heck were they asking? So there's always that, right? It's like, I don't remember the question now. We solved this. What was the question? Determine the time in minutes that Josephine must run the remaining 7 kilometers. Okay. So, you know how you answer a written response? You repeat the question as a statement. So it said, determine the amount of time Josephine must run the remaining. So we just are going to rewrite this as Josephine must run the remaining 7 kilometers. Josephine must run.
What's up, Warriors? Welcome back, and these are your announcements for today.
Forever immortalized on YouTube.
Students who wish to take off the computer technology center will high school. One-way transportation began yesterday. Students attending school classes required to transportation CTC.